Welcome to my video on perfect squares. So in this lesson, you're going to be able to determine the square root of a perfect square less than or equal to 400. So last year, you covered up to, I believe, 144. And actually, um, if you know your basic multiplication facts up to the 12s, then you know your perfect square is up to 144. So a perfect square is the product of any number and itself. So perfect squares are the squares of whole numbers. So for example, 8 squared is 64 because 8 times 8, and that makes 64 a perfect square. So we're going to look at the first 20 perfect squares and we're going to complete the table below. So we have 1 squared is 1, 2 squared is 4, 3 squared is 9, and you should be able to say these in your head as we go. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. Now, I don't expect you to know anything past this. Now, I'm going to work out a couple of these by hand because these, if you were to get a perfect square question, it would be on the non-calculator part. So we got to know how to multiply these together without a calculator. So I'm just going to pick 2 of them to do by hand, and then we'll just fill in the rest. So you can either do it in this little spot here, or I think if you look at the bottom of page 2 in our notes, you can squeeze it in there at the bottom. So the first one is 13 squares, so we're going to do 13 times 13. Okay, 3 times 3 is 9. 3 times 1 is 3. Now remember, in the second line of multiplication, we drop a 0 because this 1 is in the tens place. So we drop the 0. 1 times 3 is 3, and 1 times 1 is 1. So when we add this up, 9 plus 0, 3 plus 3, 6, and 1 plus nothing is 1. So 13 squared is 169. Now in that same space, you can do 14 squared. So we're going to do 14 times 14. All right, 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5. Now remember, drop the placeholder because we're now multiplying the tens place. So 1 times 4 is 4, and 1 times 1 is 1. Add that up. 6 plus 0 is 6. 5 plus 4 is 9. And 1 plus nothing is 1. So we get 196. Now we're not going to work every single one of these out. When I did this, excuse me, lesson in class, I actually had each group work out 2 of these. So now we have 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. So now I want you to see a pattern here, because if you can identify this pattern, you can usually narrow your choices down to 2. So let's say we knew the perfect square ended in a 6. Okay, so we're looking for 256, and we know it ends in a 6. So if I go from 11 to 20, okay, I can take a look at, for example, 11 squared. Excuse me. So if you take the last number of both 11, so 1 times 1 is 1. So we know that 11 squared ends in a 1. 12 squared, so 2 times 2 is 4, so we know 12 squared ends in a 4, 144. Okay, 3 squared, 3 times 3 is 9, so we know 13 squared is 169. 4 times 4 is 16, so we know 14 squared ends in a 6, so 196. And then we can narrow it down. So we know that 4 times 4 is 16. We also know 6 times 6 is 16, so they both end in a 6. So instead of doing all 11 through 20, we would just pick 14 times 14 and 16 times 16, rather than trying all of them, okay? And that would also work for, if we ended in a 9, then we would pick 17 times 17 to do and 13 times 13 to do. So if you know those tricks, you can save yourself a lot of time. And also, if you think logically about the numbers, you may not even need to multiply once we get enough practice with perfect squares. So squares are geometric figures, okay? And this is where perfect squares came from. So a side creates a perfect square. So for example here, okay, each side here is 1. So in the area of this square is 1, so the square root of 1 is 1. Okay. Now this, and we can put a 1 here, this one has an area of 4, so the square root of 4 is 2, because each side has a length of 2. So look, 1, 2 boxes. Okay, this one has an area of 9, and look at its length. It has a length of 3 boxes. So let's draw another one. So if I wanted to draw a length of 4, I would make sure, and hopefully your box looks better than mine. Okay, now we have an area of 16, and the length of each side is 4. So let's do one more here. So let's do 5. So each 3, 4, 5. So here the area would be 25. The square root of 25 would be 5, because each length has a side of 5. So this is where perfect squares come from. So now let's do some practice with perfect squares here. Now let's look at the chart and identify which ones are perfect squares and which ones are not perfect squares. Okay, now you're going to be able to start at the top, but since you can't see everything here, I'm going to start down here. But you, of course, start at the top. So 25, is that a perfect square? Yes, because 5 times 5 is 25. 44? No. 116? No. 225? Yes. 81? Yes. And I'm sorry, 225, 15 times 15. 81, 9 times 9. 16? Yes. 4 times 4. 121? Yes. 11 times 11. 125? No. 32? No. 64? That's a yes. 8 times 8. 144? That's a yes. 12 times 12. 150? That would be a no. 169? Yes. 13 times 13. 361? Yes. 19 times 19. 18? No. And 196? Yes, because of 14 times 14. Okay, so now we know what's a perfect square and what's not a perfect square. And if you were having trouble with those, all you have to do is just multiply a number by itself and see which ones you actually get. Okay, so now these are more like SOL type questions, something you might see on a quiz, a test, or maybe even an SOL. So which one would go in the blank? Now, we have 144. We have 169. Okay. And then the next one. So we know 12 times 12 is 144. 13 times 13 is 169. So we're looking for 14 times 14. And what does that equal? 196. So we would circle that one. Now 225, that would be 15 squared. So we know that this one's 14 times 14, so we can also circle 14 squared. Now it says plot the square root of 289. So this is the square root symbol. So in other words, this question says, what times what equals 289? Or another way of saying this would be, if I had an area of 289, what would the length of one of its sides be? So if that, of course, we're looking at, it ends in a 9. So I'm looking at 13 times 13, because 3 times 3. And I'm looking at 17 times 17, because 7 times 7 is 49, and that ends in a 9 as well. So I know that 13 squared is 169, so it must be 17 squared. So I would put a dot on 17. Okay, moving right along. Number 3, which one would go in the blank? So I have 16, 17, 18. So I'm looking at these perfect squares, and I need to figure out which one is the square root has an answer of 18. So I know that 8 times 8 is 64, so I'm looking for one that ends in a 4. And the only one that ends in a 4 is 324. Okay, what is the square root of 256? So let's use that trick again. So I know it's more than 10, so let's see, between 11 and 20, which ones end in a 6? So let's see, 4 times 4 is 16, so that ends in a 6, and 6 times 6 is 36, so that also ends in a 6. I know that 14 squared is 196, so it must be 16. So that means if a square had an area of 256, each length would be 16. Now it says, which of the following could replace the question mark? So let's follow the pattern here. We have square root of 121, square root of 144. So the next one would be square root of 169. And we also know that the square root of 169 is 13. 3 times 3 is 9, and that also ends in a 9. Okay, that concludes our notes on perfect squares. I hope you have a great day.